Bismillahirrahmanirrahim. This is me Atiyah Subhani and with me is Iman Hassan, and today we are here to talk about the building patterns in software design and architecture. First of all, let's introduce what building patterns are. So here we go. This is basically a design pattern that helps to create complex objects in a simple and organized way. So we can say that the building pattern is used to construct a complex object step by step, and it separates the construction process from the final representation, making it easier to manage. So this is a short description of what building patterns are. Moving towards the uses of building patterns, here you can see there are four basic uses written. The first one is constructing complex objects and extraction of creation logic, immutable object creation, and customizable configurations. So this is basically like you can say that it is useful um, in creating an object with many parts or configurations, and it is useful when you want to make the object creation process easy to understand and maintain, or you need different representations of same construction process. Like you can see is written the building pattern promotes code reuse and maintainability, and the building pattern facilitates the creation of immutable objects, ensuring their state cannot be modified after the construction, and many more. It is also allowing for the flexibility and control over the construction process, and it allows the clients to create objects with different configurations without the need to expose all the potential options. So these are the basic uses of where building patterns are used. Moving towards the next slide, you can see the basic components written here. So first of all, the obvious and the first one component is the product. It is basically the complex object that is being built. And then comes the director, that is responsible for constructing the final product by coordinating the steps in the building process. And this is basically the class that controls the building process using the builder. And then comes the building interface that defines the methods that the director will use to build the product, and this allows for the flexibility in the construction process and then continue with the process. So the last one and the most important one is the concrete builders, that is basically a class that implements the builder and provides specific parts and assembly processes. So it is like this allows for the creation of different product representations basically. So it is quite easy and simple to understand. It is very simple. So here you can see a Java code example of building patterns. The building pattern is like used to create complex objects and separating the construction process from the object representation. We can see this Java program here, where you can see that first of all we have defined the product class. I'm sorry you cannot see the complete picture here, but this is what is written in the code. It is basically describing the foundation, the structure, and the roof with setters for each part, and then like it is defining the builder interface and the concrete builder class. So here's a more detailed explanation of the Java code, which is just describing the builder class, the director class, and the product class, where the builder class is responsible for constructing the complex object, and the director class provides the steps to provide the object, and the product class you can see that represents the final complex object being built. So this Java code is basically demonstrating the implementation of the builder pattern, which is creational design pattern that separates the construction of a complex object from its representation. And the key components are the builder class, which encapsulates the logic for constructing the object, the director class, as you can see, which provides the high level steps for building the object, and the product class that represents the final complex object being built. And this separation of concerns allows for greater flexibility, modularity, and testability in the construction process. So finally we are creating the director class and using it to build the process. So to sum up, we can say that the building pattern helps to construct the complex objects in a step-by-step manner, making the code easier for us to manage and understand, and we saw how to implement this pattern in Java with a simple example, and now my friend Iman is going to explain more about this. Thank you so much for watching the video.
Assalamu alaikum. My name is Iman Isan and I will tell you about the advantages of the builder pattern. The first advantage is flexibility. Flexibility allows step-by-step construction of complex objects, enabling different representations using the same code. The next advantage is readability. Readability, it breaks down object construction into clear steps, making code easy to understand and maintain. Now the next advantage is immutability. It promotes creation of immutable objects, ensuring consistency and thread safety. The last one is testability. The builder pattern separates construction logic, making it easier to test different configurations and states. Now we will talk about the use cases for the builder pattern. The first use case is complex object creation. When an object requires numerous parameters or involves complex construction logic, the builder pattern simplifies the creation process by breaking it into manageable steps. The next one is immutable object. The builder pattern is ideal for creating immutable objects as it allows setting all necessary properties during construction and prevents modification afterwards. Now the next one is flexible constructors. It provides flexibility in object creation by allowing optional parameters in different configurations, avoiding the need for multiple constructors with various parameter combinations. The last one is inheritance and variation. The builder pattern supports creating variations of a product, accommodating inheritance hierarchies by allowing different concrete builders to create objects with slight variations. Now we will talk about examples in real life. Imagine ordering a customer car online. You start by selecting the model, then choose the color, engine type, transmission, and additional features like a sunroof or GPS. This step-by-step process resembles the builder pattern. It makes it easier to customize our car while ensuring that once it's built, its configuration remains unchanged. The builder pattern also allows the car manufacturer to offer different models with variations in feature, accommodating various customer preferences. Now we will talk about the challenges in the builder pattern. The first one is complexity. As the number of configurable options increases, so does the complexity of the builder pattern implementation. Because managing numerous parameters and their combination can lead to verbose builder classes in client code. The next one is overhead. Using the builder pattern can introduce overhead, especially for simpler objects where the construction logic is not overly complex. In such cases, the builder pattern might add unnecessary complexity to the code base. The last one is validation. Ensuring that the constructed object is in a valid state can be challenging with the builder pattern. It's important to validate the input parameters and the construction process itself to avoid creating objects in an inconsistent or invalid state. So now we will conclude the builder pattern. In conclusion, the builder pattern is a powerful tool for creating complex objects step by step, offering flexibility and immutability. To use it effectively, ensure your builder class is readable with clear step by step instructions for object construction. Validate inputs and construction process to maintain object integrity. Thank you.